This is Advanced Math, Lesson 1.8. Title is Rational Expressions Involving Roots. Rational expressions involving roots. Number 1, 4a squared over the square root of a squared plus 1 plus the square root of a squared plus 1. I'm going to white this out. I will be putting it back, so if you're writing in pen, you do not have to erase or white out. This is how it's going to look on a worksheet or a quiz or a test. It's going to look just like this. I'm adding two fractions. In order to add two fractions, I need to find a common denominator, and it is asking us to simplify here. So I'm going to make it a fraction by putting it over 1. This is not a complex fraction. I repeat, this is not a complex fraction, meaning I'm not clearing out my denominators. I'm going to rewrite it using a common denominator. A really quick side note, I often have kids ask, can I cross-reduce? No, 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 you are not allowed to cross-reduce because that is a plus sign, not a multiplication. If that was a multiplication symbol, multiplication sign, you can cross-reduce. With addition or subtraction, you cannot. All right. I'm hoping everybody recognizes that the square root is, the common denominator is a square root of a squared plus 1. Another quick side note, I often have kids say, they'll ask this, is the square root of a squared plus 1 equal to a plus 1, because they're both perfect squares. Square root of a squared is a, square root of 1 is 1. Can I do that? The answer is no. And if you think about it, the square root of 25 plus 4, if you did it this way, you would say, oh, that's 5 plus 2, which is 7. And if you did it this way, you get square root of 29, which does not equal 7. So you can see whenever there's plus or minus signs inside the square root, you can't just pull it all out. It stays inside. Okay. One more time, you cannot simplify this. It is what it is. But our common denominator is indeed this. So I'm going to multiply top and bottom by a squared plus 1. This one I'm not multiplying by anything because it's already taken care of. So that top is going to stay 4a squared plus. I'm hoping you see that these two things are exactly the same. So the square roots will undo each other. A squared plus 1, the square root of that times the square root of a squared plus 1 is simply a squared plus 1. The radicals undo each other. Like root 5 times root 5 is 5. Same concept. Terms, 5a squared plus 1 over the square root of a squared plus 1. Or 5a squared plus 1 over parentheses a plus 1 close parentheses raised to the 1/2. Remembering from math 2 that a square root is the same as a 1/2 power. You don't have to change it to that, you just need to know that it's the same thing. Number 2, x over the square root of 2 plus x plus parentheses 2 plus x close parentheses raised to the 1/2. Again, I'm adding, so I need to find a common denominator. So I'm going to make this over here a fraction by putting it over 1. And then I'm also going to make a change before I find my common denominator. These two bases are the same, the 2 plus x's, 2 plus x and 2 plus x, but this is written as a square root and this is written as a 1/2. It doesn't matter which one you pick. Pick one, write them both as square roots, so write them both as 1/2. And again, it's not even mandatory requirement that you do it, but I try to keep it simple and keep it clean, all looking the same. Because I use square roots up here, I'm going to use 1/2 power on this one just to get the practice. Alright, so I just simply changed them both to the 1/2 power. And as before, we cannot cross reduce because we are adding, not multiplying. And the common denominator is 2 plus x raised to the 1/2. First fraction's already taken care of. That's going to stay x. The second fraction, I'm going to multiply top and bottom by the denominator because the denominator is 1 and I want it to be 2 plus x raised to the 1/2. 2 plus x raised to the 1/2. 1 times this is the common denominator. Now think up here, you have the same base, and when you're multiplying the same base, you add. If it was x squared times x cubed, you would do 2 plus 3 and get x to the 5th. We all agree with that. You're doing the same thing here. Bases are the same, so you add the exponent. So it's plus 2 plus x raised to the 1/2 plus 1/2 is 1. Of course, you don't need that 1 power, and I will take it off on the next step. I'm just trying to show you that the bases stayed the same, and 1/2 plus 1/2 is 1. All right, x plus 2 plus x over 2 plus x raised to the 1/2. And really quick side note, if you had left these in radical form, the radical times the radical, it would have undone each other like it did up here. So either way, it works out the same. All right, 2x plus 2 over 2 plus x raised to the 1/2, GCF. And since the GCF does not allow me to reduce, this answer would have been safe as well. You could even write the bottom as 2 plus the square root of 2 plus x, or leave it like this, totally up to you. That is the answer, either one of these for number 2. Number 3. Square root of 1 minus m squared plus m squared over the square root of 1 minus m squared all over 1 minus m squared. All right, now we're dealing with a complex fraction again. So this is the one where we multiply everything by the same thing and clear. First thing I'm going to do is make these fractions. All right, since it's a complex fraction, I multiply everything by the same thing, by the common denominator, to clear. The common denominator in this particular problem is square root of 1 minus m squared. Square root of 1 minus m squared, and the square root of 1 minus m squared. All right, let's go ahead and clean this up and see what happens. First one here, excuse me. First thing here, the bases are the same, 1 minus m squared, and they both have a square root, so the square roots will undo each other. Again, it's like root 5 times root 5 is simply 5, because the square root of 25 is 5. The radicals or the square roots undo each other. Same thing here, they undo each other. 1 minus m squared plus these two reduce, gone and gone, plus m squared. I can see that's going to clean up. I'll do it on the next step. These are like bases, but this has a square root and this one does not. So here is what I'm going to do. I'm going to leave the first one as it is, and I'm going to write the second one with the 1/2 power, and we'll see why in just a little bit. I'm leaving the first one as it is, 1 minus m squared, and this one here I'm writing to the 1/2 power. You may be wondering why when I didn't do it anywhere else. You'll see why in just a little bit. Okay, negative m squared and positive m squared is 1. And now we're going to see why we changed it. I'm going to flip this over. Earlier we talked about adding exponents. X squared times x cubed is x to the 5th. And you do that when the bases are the same. Same concept here, but what would you do if the exponents were fractions and you had x to the 1st times x to the 1/2? The bases are the same and you still add the exponents. X to the 1 plus 1/2 is 1 1/2. 1 plus 1/2 is 1 1/2. And then you multiply and add to make it an improper fraction. So 2 plus 1, that would be 3 over 2. All right, so this concept here you'll need to know. When you're adding exponents and you're working with fractions, you just do it in your head, do it by hand, common denominator if you want. I just know that 1 plus 1/2 is 1 1/2 and 1 1/2 is 3/2. All right, so with that being said, these two bases are the same, so it's going to stay the same. 1 minus m squared. This has a power of 1. This has a power of 1/2. And 1 plus 1/2 is 1 1/2. And 1 1/2 is 3 over 2. So my power in the denominator is 3/2. You may be thinking, ugh, that's gross. But it's advanced math. And it is what it is. It's actually a beautiful answer, and we can work with this. Again, 1 plus 1/2 is 1 1/2. 1 1/2 is 3/2. Base stays the same, just like it did here, and the power is 3/2. And that there is your final answer. All right, number 4. This is a longer problem, so you want to make sure you're giving yourself enough room to write it all down. Parentheses t squared minus 6, close parentheses cubed, parentheses t squared minus 3, close parentheses, parentheses 4t, close parentheses, take away, parentheses t squared minus 3, close parentheses squared, parentheses t squared minus 6, close parentheses squared, parentheses 6t. All over, I know, t squared minus 6, parentheses to the 6th power. Whew. It's exhausting just writing that down. I will make a note that this is on the test. This is a test question. I know you're looking at it thinking, what? How can I do it on the test? It is doable. Okay, first thing I would suggest is that you recognize that these guys are typically put out front, so you can rewrite it with the 4t in the front and the 6t in the front. That's how I probably would have done it. If I saw this on the worksheet when I was doing my, if I were writing it down on my own to do my work, I would put this in the front and this in the front. I'm just showing it to you like this, so when you see it this way, you recognize that these are the coefficients, the 4t and the 6t. All right, let's look at, this is a GCF problem, by the way. I'm going to cover this guy, and I'm hoping you recognize that there are two terms. First term, second term, which means it's not in factored form. And if it's not in factored form, I cannot go reducing things. Again, I cannot reduce because it's not in factored form. First term with 3 factors, second term with 3 factors. I cannot reduce because it's not in factored form. So what I'm going to do is GCF. Okay, so I'm going to do what would be my coefficients first. What's my GCF for 4t and 6t? I'm hoping you see that it is 2t. Okay, I have more. All right, so I've already done this piece. I'm gonna do, it doesn't matter, they're not in the same order, like they're here and here, and then here and here. I'm just going to do the t squared minus 6 first. It doesn't matter if you did the t squared minus 3 first. Okay, t squared minus 6, and you're looking to see, you're looking to see which one has the smaller exponent. That's this one here. So t squared minus 6 squared. Thinking if you were doing just a regular GCF problem, I'm going to show you really quick. If it was like this, x squared y to the third minus x to the fifth y, and you were looking at your GCF, you would take out an x squared because that's the smaller one, and then the y because that's the smaller one. And you'd be left with y squared minus x to the third. Make sense? So that's what we're going to be doing here, taking the smaller exponents for the GCF. So t squared minus 6 squared, and on the t squared minus 3 to the first power is the smaller one. So t squared minus 3 to the first power, and then my big exaggerated parentheses for what's left. Okay, so 2t came out from this. T squared minus 6 to the second power came out for this, and t squared minus 3 to the first power came out for this. All right, so 2t times what is 4t? 2. 2 times 2 is 4, and the t is there. Okay, t squared minus 6 squared, I need it cubed, so I do need one more. T squared minus 6 to the first power. You do not need to show the first power, I'm just putting it there for now. T squared minus 3 to the first, t squared minus 3 to the first, taken care of. And I've already addressed the 4 too. I put it up here in the front. The 4t, sorry. I already addressed that here in the front. Take away. Okay, 2t times what is 6t? I'm hoping everyone sees it's 3. 2t times 3 is 6t. Okay, I'm here. T squared minus 6. Quantity squared, it's all taken care of. Now I'm here. I need it to be squared, t squared minus 3 squared, and this is first. So another t squared minus 3 to the first power so that it adds up to the squared. All right, now we do have to clean up in here to see if there's any like terms. Oh, if there's any like terms and anything to factor. Okay, all over t squared minus 6 raised to the 6th power. Okay, so I'm going to do two things at one time. I am going to clean this up. I'm also going to erase these powers so that I know that I can distribute the 2 and the negative 3. Okay, so before I do distribute that, I do want to address this guy out here. Actually, no, I'll save it. Let's just continue working and cleaning up and see what works. Okay, I'll reduce at the end. I am well aware that I can, but I will save it for the end. I'm going to finish cleaning up in the numerator. Okay, so I have this, and this gives me 2t squared minus 12, take away 3t squared plus 9. I have like terms here and here, so I am going to continue. 2t, t squared minus 6 squared, t squared minus 3. That's going to combine to negative t squared. Negative 12 and positive 9 is going to combine to negative 3. All over t squared minus 6 to the 6th power. Okay, I'm done as far as factoring goes. I've factored as much as I can. So I'm going to reduce. And if you want to take out this negative, you can. If you want to leave it in there, you can. It's totally up to you. All right, there's 2 here and there's 6 down here. When I reduce, how many sets are going to reduce? 2 of them. So this is gone completely. And if I reduce 2 sets, that means 4 are left at the bottom. So t squared minus 6 raised to the fourth power. Do you see that? Reduce, this one's gone completely. This one becomes fourth power when you subtract 6 minus 2. All right, so again, you can leave the negative in or take it out. I'm going to show you what it looks like if I GCF it. I'm going to put in the front 2t, t squared minus 3. Taking out the negative here gives me a positive t squared plus 3 all over t squared minus 6 raised to the fourth power. And if you did not want to take out that negative, you would have just left it in there, and that would be positive out here. Again, this is on the test, so I would make sure that when it comes time to study, you go back and you look at this one again. Maybe start from the beginning, cover all this, rewrite that problem down in a separate piece of paper, try it on your own. You have all the work in your notebook, so you can go back and check it later. And that is it for this lesson.